Okay, you should have a thing pop up for Slido that we'll be using. Turn that on for everybody. Okay, so welcome. Sorry about those technical challenges there. Oh wow, that's me on top of me. That may not be okay, there we go. Thank you for coming. Thumbs up. Did everything sound good? Did we get the audio stuff resolved? Yes. Okay, awesome. Okay. Sorry about that. We had loop back for something, and of course, I didn't think to go ahead and mute everybody else. But it looks like we got it now. Okay, so today we're doing an ultra focus, just 30 minutes, looking at the paradox of team size. So let me get through. Oh, there we go. Skip that. Okay. But before we get into that, I want to let you know next week we've got Austin Chadwick is going to be talking to us about what mob programming is not. I love this image of a mob of angry farmers yelling at a computer screen to program. Anyway, Austin Chadwick's been doing mob programming for a long time, and he runs the Mob Mentality podcast. So really looking forward to that. That's going to be a lot of fun. Okay, so talking about the paradox of team size. So a lot of the statistics from this talk is going to come from qsm.com. They have a large pool of projects. So they pulled all their information from different projects and said what's making these projects successful, what's making them not. I think they had about 13,000 projects. And I'm curious as we go through this if the statistics match with what you've experienced on teams. So they took 13,000 projects, and then what they did is they said, let's divide these into two groups. And we'll have the group where there were 5 or fewer developers, and we'll have the group where there are 20 or more developers. So from those two groups, they ended up with, I think on average, if I understood the stats correctly, on average, the group of 5 or fewer ended up with an average of 4 people per team in that particular group. The larger groups ended up with 32 people on average in the larger groups. So then they normalized the data and figured out how to fit a way to say how long did it take these teams to deliver a project that has 100 lines of code for the average project side. And then ask which team finished first. So based on that information, just take a guess here in Slido and let us know which team you think was most likely to finish first. Was it the teams of 20 or more, the teams of 5 or less, or do you think it worked out to be the same? Okay, is that popping up for you guys? Let's see, did I not get it enabled? Oh, that's interesting. It's not showing on my thing correctly. Okay, let me jump out of this and start it in a different way. Okay, is that not showing? Oh, there we go. Okay, I'm sorry, I didn't have the thing. So everybody guessed, or 70%, 7% of you guessed that it was the teams of 5 or less. 15% said it was the same. It actually was, and this kind of surprised me, it was the teams of 20 or more, but we're going to dig into that here in just a minute. The teams of 20 more actually finished faster. So the large groups finished their projects first, and they were done in about 5 to 6 months. But next question for you, how much longer did it take the small groups to finish their projects? How long do you think it took the small groups to finish their project? Was it the small groups took 1 week longer, 1 month longer, 3 months longer, 9 months longer, or a year longer? And there's no right or wrong answer. This is just about the average of this particular data set. So your experience may be very different than what's here, but I think this is still insightful to kind of see what people were running into. So we got somebody saying, guessing the point is that 5 can be as or more productive than 32. So we will be looking at that. Okay, so let's see what we have here. It actually was 1 week. So 26% of you guessed the 1 week. So within a team of an average size of 32, they were able to finish 1 week faster than the team that had an average size of 4. Next question. What did the defect rate between the teams compare? How do you think the defect rate compared between the teams? So small team had 5 times the defects of the large team. Large team had a lot more people looking at stuff. Maybe they could have more attention to quality. Small team had 2 times the defects of the larger team. Small and large team had same number of defects. Large team had 2 times the defects of small, or large team had 5 times the defects of small. What do you think was your intuition tell you? And we'll see. And I think most of these you could probably make a case for based on more people doing testing or fewer people doing testing. But the actual answer was the large team had 5 times the defects of the small team on average. So next thing that I think was an interesting point from this is, what about the cost? So let's see what your intuition is on the cost. Do you think one team size was significantly more expensive than the other? So large team was much more expensive, small team was much more expensive, or cost was similar for both sizes? Okay, so most of us are thinking the large team was much more expensive. And the answer here is it actually was the large team was more expensive, which makes sense, right? If you've got 32 people on a team and you've got a project that goes for 5 or 6 months, and you versus 4 people on a team, a project that goes for 5 or 6 months plus a week, the larger team's going to be more expensive. But how much more expensive do you think the large teams were? So how much more were we paying for that extra for that week? So get your opinion in on what you think, and then we'll look at what the answer was from the data. And it actually was 7 times. So they spent 7 times more. The cost of the larger teams cost 7 times more than the cost of the small teams to deliver the same thing. The small team delivered a week later than the larger teams on average. Now, we're going to talk a little bit later about whether that is correlation or causation. I'm not convinced it's all causation. We'll talk about why. So the small team, on average, took 24.5 person months, and they were using calculation of $12,000 per month per person, which this was a number of years ago, so it may be a little bit low now. But large teams took 178 person months to deliver the same thing. So we had a cost of $284,000 for the small team to deliver the same size project as cost $2.1 million for the large team. Now this is really, really significant. And I think in a lot of organizations, we don't do this type of math and really think, because in our mind, it's so ingrained. We so much believe that if we add more people to things, we can make it go faster, that we rarely take the time to go through and see if being faster, if we're going fast enough to actually justify the expense we're adding to it. So in this case, we've got the 284,000 versus the 2.1 million. That's $1.8 million difference. That's how much, on average, these teams were paying in order to get software 1 week early. They were willing to pay, or based on what they were doing, they were willing to pay $1.8 million to get software a week early versus what would happen if they had been dealing with a smaller team. So just in the comments, does this resonate with what you've experienced? Is this surprising? What do you think? What's your reaction to these numbers? And keep in mind, this is average. Your organization may be completely different. You may find that you get really, really good results with large teams. It's not that can't be true, and this can fit the average for teams. So I see people saying, oh, wow, and surprise faces. So now here's where I think it's really interesting to start thinking about. So this is a comic from XKCD. And this guy says, I used to think correlation implied causation. So meaning if 2 things happened at the same time, that means that one caused the other. Then he says, then I took a statistics class. Now I don't. And the girl says, well, it sounds like the class helped. He said, well, maybe. He's not sure. He now doesn't think that, but he doesn't know if it's really caused by taking the statistics class or if it just happened to happen at the same time. So this, I think, is important whenever we're looking at data to really think about is the fact that there was a larger team the reason it was more inefficient, Or maybe there are other things that go along with large teams that make it easier to be inefficient just in the way we work. Is it the size of the team that really matters here? And can we make a large team efficient? Because on those other things, if we were able to make the large teams efficient, we might be able to get the software really, really quick. The other thing I didn't mention about that, when we think about the $1.8 million, in some cases, a week's worth of not having the software would absolutely be worth $1.8 million. Now, for a lot of us, that's not the case. For a lot of us, an additional $1.8 million is we'd be better off having the $1.8 million to spend invest in other pieces of software rather than just getting it a week early. So here's some potential issues with larger teams. Oops, I've got a missing bullet there. So some potential issues with larger teams. And the reason I want to look at these is because these are things that may point to the cause of larger teams being less efficient, but it doesn't necessarily mean that large teams always have to experience these things. So one thing that happens with larger teams is you're likely to have higher cognitive load. There's a lot more people to interact with. We're also likely to be less selective and have a lower average skill. So if I need to staff a team with 32 people versus if I need to staff a team with 4 people, I might take people in order to get the body count probably isn't a good way of saying that. Sounds like it's a murder or something. In order to fill all the seats, I may take people when I have 32 that I would be less likely to take if they were lower. Yes, there are frustrating statisticians, and I want to make sure we're thinking about what actually causes it, not just saying that the large number doesn't work. I've got some friends that do a lot of work in this space, and they think you can absolutely have large teams, and that works well. You just have to make sure you don't succumb to these types of things that can be harder with larger teams. Another reason, more bureaucratic overhead. If we're dealing with a large team, there may be a lot more hoops to jump through than if you've got a really, really small team. And this is one that I think is particularly interesting, there may be a higher experimentation cost. And we're going to look at these things a little more detail. So cognitive load. Let's say I've got 2 people working together. We're just working together. I've got 2 points of interaction. This is a lower there's not a lot of load here, right? I need to keep track of what I tell this person, what this person tells me. If I up that now and I've got 6 people, I dramatically increase the number of interactions I need to keep track of. And so this is with 6, and I think so here's a drawing right here with 12. So imagine 32, and I didn't get around to drawing all the lines for 32, but you can get the idea that there's lots more of interactions to deal with when you're working with a team of 32 people versus when you're dealing with a team of 6 or 4 or 2. So cognitive load causes can be, the team size can be one, like we just looked at all those things. But there can also be a similar effect when you think about the technical tool knowledge required for a project. If you're working on a project that is using one particular language with very simple deployment and just a few tools that people are familiar with, that's going to have a lower cognitive load than if you've got 50 different tools you're trying to use in 4 or 5 different programming languages. So on a larger project, or on a project which you have more people involved with, you may be more likely to have more technical tools involved just because people have different preferences. Whereas if you're dealing with 4 people, you may have some constraints of people saying, we're going to agree on fewer tools just because we can't take on this cognitive load. Whereas in a larger team, we may be willing to take it on, but it might be at the expense of the cognitive load it brings to it. So we may think that having more people will lower the cognitive load of a wider variety of tool sets. Maybe that's not the case. Another cause is the complexity of the domain. So if I'm working on something that's really, really simple versus something that's really, really complex, there's going to be more cognitive load around that. We may be more, so one thing the stats could be telling us, although based on the study, I don't think this was the case, it could be that just when you have more complex things to understand, we tend to load it up with more people. In that case, it wouldn't be the team size, it would just be the complexity. My experience has been that's not usually the main cause of cognitive load, and that's not usually the main driver of team size. But in some cases, it could be. Another cause of cognitive load would be the work environment. So if you're in an environment that has lots and lots of hoops to jump through, lots of very, very complex things to deal with when you're trying to look at change management, and lots of complexity around human resources and forms to be filled out and reports and lots of reporting structure and stuff like that. That all adds cognitive load as well. And it could be that with larger teams, we're in situations where we have more of that type of cognitive load. So it's not really the team doing it, it's just the things that we happen to build around large teams that maybe don't need to be there. So, in your experience, what has been the biggest cause of cognitive load on teams that you've seen? Like things that just take lots of time to think through and slow the process down. Is it the team size? Is it technical tools? Is it the domain complexity? Or is it the work environment? So the team size would be you're dealing with situations where just keeping track of all the people on the team and who you need to find things from is what's really slowing you down. Complexity of the domain would just be we're working with something that's really, really tough to understand. Maybe it uses very complex mathematics or something like that, or the rules are very unclear or those types of things. So this is interesting to see. In my experience, and keep in mind your experience, it looks like most of us are saying the complexity of the domain. In my experience, and this is probably a little bit biased because oftentimes when I'm coming in to help a team, I'm often trying to deal with reducing the complexity of the domain by using behavior-driven development to try to bring that complexity down. But in my experience, the thing that really takes on a huge amount of cognitive load is the work environment and the technical tools, and particularly the intersection of those two things. So when you're in a work environment that requires you to use certain tools or you don't have access to the things that you need in order to be able to actually move forward. So I've got a CI/CD pipeline that I'm not allowed to touch and I can't see what's inside of it, and I need to log something's not working right and I need to log out what's happening at this particular place in time, but I can't change it. That's a place. And okay, I see some cross team dependencies. I would assume that that would either be part of the work environment in the stuff we've got here. So your work environment is set up to where teams can't deliver something all the way on their own, or could be more that way. But this isn't a exhaustive list, right? There's lots of other things that could be in here. These were just the ones I was thinking of. But don't assume that this is the only thing that could cause cognitive load. The spaghetti code could be as well, right? Dealing with basically technical debt that you're dealing with on your software project. But like I was saying, the thing that I've seen, the biggest cause of cognitive load I've seen, particularly in large organizations, is where the work environment intersects with the technical tools. So I've got a tool that doesn't necessarily do what I want, or I don't have access to it to be able to change it or even see what it's doing. And the work environment prevents me from actually getting that access that I need. Okay, so next question. What do you feel is more important for a team's success? Is it this? So think of this in two ways. We've got the total sum of skill on one team. So like if we added up all the skill on the team, or the average skill on a team. And there's not a right or wrong answer here. I was just curious to see what people thought. Technical debt could be considered part of the domain complexity. Yes. I guess it could be because you may be dealing with an existing piece of software. I was thinking the domain being more of the business knowledge needed to understand what needs to be produced. But you're right. What you're doing may be modifying that exists, and then understanding what it does becomes part of the domain. That's a good point. Okay, looks like we're about 50-50 here on the total sum of skill on the team being more important to the team's success and the average skill on the team. So, and like I said, I don't think there's a right or wrong answer here, but I will suggest that if you're trying to get with larger numbers, if you're dealing with 32 people, you probably are going to be dealing with a lower average skill. There's a very high chance you're going to be dealing with a lower average skill on a team to fill out that many seats than what you'll have if you're only selecting very carefully for 4 people. And the idea of the total skill on the team, if we add everybody up, it might be a thing where we say, I guess the question is do we count things twice, right? If we've got the total skill on a team, but this person has a skill, this person has a skill, and we add them together, maybe our total skill, sum of the skills is going to be really, really high. If we say the sum of the skills and don't double count things, maybe the number would be a little bit lower. But I think this is an interesting thing to think about when it comes to teams, is whether or not we're constructing our team in a way that we want a higher average skill for people on the team, like the median of the skill level of the developers is higher, or if we're more interested in having a large number of maybe lower skilled people, but larger number of them, because we can do more things in parallel. These aren't necessarily good or bad. It may depend a lot on what the particular problem is that you're trying to address. Yes. In a lot of cases, and Astrid, you mentioned you'd go with median skill. Probably. I think in a lot of places we overvalue the sum of the skill and undervalue the median skill. But like I said, it depends on what you're working on. Okay, so less selective or lower skill. So are larger teams more likely to fill seats? So these are some reasons that we may see these results. It may be true that larger teams are more likely, it may be true in your organization, that larger teams are more likely to try to fill seats with people that may not be quite as good as some of the as what they would do if they were only selecting 4 people. And keep in mind, not every developer, there are developers that bring negative value to your team. There are developers that will actually slow things down more than they actually help. And if you're selecting developers, that may be more likely to happen with a large team than with a low team. I mean, you could obviously select them with a small number of people as well. But with 32 people, you're going to have a harder time getting above a certain level. So thinking in terms of what's the average skill of 4 developers versus 32, and asking, is it harder to efficiently leverage skills on a large team? So even if we do have a bunch of highly skilled people on a larger team with 32 people, maybe it's actually harder to leverage those skills. Whereas when we're in a small team, we're able to take more advantage of what people bring to the table. So it may be true that in some work environments, having 32 people, even if they are all at the same level in skills, it may be harder to take advantage of that just because of other, like the cognitive load and those things that we talked about, which might suggest breaking them into smaller teams, particularly if they can deliver things independently. We've also got more bureaucracy on larger teams. And when I say this, when I wrote this, I was like, it sounds really bad, but some of this may be necessary, right? If you've got 32 people, it may require more management involved than if you've just got 4 people. If you've got 32 people, you may need to have more guardrails just because there's more things happening at the same time. That's not necessarily bad, but it is something that may make the efficiency of a larger team be less per person than of a smaller team. There also may be less trust. And some of this has to do with just how many people can you know well. 4 people you may be able to develop really, really good trust with. 32 people, there may be still a lot of people that are kind of on the edges of the people you know and trust well. High experiment costs. So this is one that I think is one of the more important things that often gets overlooked. How are we doing time? Okay, good. A lot of software development is experimental. We're trying something. If it works, we want to keep doing it, but we may try something and decide, hey, we tried using this framework. That's not a good idea. We tried it for 2 days. We now know that's not a good idea. We're going to try this next thing. There's a lot of this kind of back and forth experimenting. And I think if we approach a large team with the idea that if the team is much, much larger, they will be able to experiment much, much faster, we need to make sure that that's actually true. So let's say with a team of 4, we do 4 experiments per week. I'm just saying 1 experiment per person. And that's what happens with a team of 4. So there's 4 things that we try and then figure out if it's going to work or not. It would be easy for us to assume that with a team of 32, we're going to be able to do 32 experiments per week. But on a lot of the teams I've worked with, I've actually found that the amount of things you can experiment at a time, if they're all working together with a team, are more constrained by the amount of time that passes than it's constrained by the number of people that are involved in it. In other words, if you can do 4 experiments a week with a group of 4 people, you may only be able to do 4 experiments a week with a group of 32 people. And what that's going to mean is it's going to take you're going to be in a situation where a lot of the learning becomes much more expensive when you've got 32 people than when you've got 4, just because you've got the burn rate is so much higher. And if you're not able to effectively experiment more rapidly, that burn rate may put the project at risk, or that burn rate may represent that $1.8 million or a big portion of that $1.8 million. So those are some things to really watch for. So in thinking in terms, how long does it take a distributed? So the other piece of the experiment, the other thing that may slow it down, is even if you do the experiment and you experiment really rapidly, the constraint may be how fast you can distribute that knowledge from an experiment to a large team versus to a team of 4 people. So would better experimentation process allow a larger team to be more efficient? And so what I'm suggesting here is, if this is the constraint that's making that large team cost $1.8 million, you may be able to invest some in improving your process of doing experiments and bring some of that cost down. So this is one area that can actually become very expensive for you when you're dealing with a large team, just because the burn rate is so high. I was working with this was a big project with the Treasury, and the original quote had been for 50 people working about 5 years, and it was going to cost about $50 million, roughly in that range. We were trying to deliver it in 3 years. And we got to a point, and the thing that made this difficult is there was a very small window each year where we could deliver. So if we got to the 3-year mark and we went a day over when we could go live, it would push it back to the 4-year mark. So we're having some discussions around that of like, do we want to do things that may take on a risk to try to get done at 3-year mark, or is it better going ahead and going to the 4-year mark? Eventually, they went ahead and decided to go to the 4-year mark, which was still a year faster and much smaller because this team only had 5 people in it. And I was talking to some of the executives, and they said, even if this ends up taking 4 years instead of 3 years, the team size has been so much smaller that this is still going to be dramatically the least expensive project we've ever had, just because they were dealing with 5 developers instead of 50 developers. So it doesn't mean that a larger team. So what I'm saying here is, a lot of that had to do with the fact that the experimentation that this team was doing cost so much less than it would have if we were dealing with 50 people. Okay, so a few takeaways. So these are things that stood out for me when I was looking at this data and putting this stuff together. So first of all, statistically, a larger team will finish slightly faster. This is an important thing to remember. There is a slight speed increase with a larger team. Now, it doesn't mean that your specific situation is always going to finish faster, but statistically, that's what's likely going to happen based on this data set. But statistically, a larger team will cost 7 times as much as a small team. So we need to really be thinking about the return on investment here, because that slight increase in speed may not at all be worth the increase in the burn rate. Statistically, a larger team will produce 5 times as many bugs. Results may be correlated but not caused by team size. So this is something that, as I was mentioning, this is really important to make sure we're remembering that just because these things are correlated and happen together, we may be able to mitigate them on larger teams if we look at what the actual cause is here. Things that lower bug production might be harder, but even more valuable for a large team. So for a large team, if we know that large teams are likely to produce 5 times as many bugs, we may be much more willing to invest in test-driven development and behavior-driven development and embedding that into the culture of the team, because it's even so much more important on the large teams. Now, I'd argue it's very important on small teams as well, but what I find a lot of times is getting a large team to actually use that effectively is a lot harder than when you're dealing with a small team. And starting with a large team may be more difficult than a small. So this is a big thing that I think is very important. If you're trying something and you're trying to learn, starting with a really large team to try to figure stuff out, you've got a much higher burn rate, but you've also got a much greater chance of having a failure based on this. You have a much greater chance of having more bugs and having a ridiculously high burn rate just by having a large team. So you're not going to get the return on investment that you'll get with a small team. And if you make a misstep with a large team and start heading in the wrong direction, it may be so much more expensive that it actually shuts the project down. And somebody Astrid is saying you can split off 4 people to make the experiment. There may be ways to manage the experiments to where you can be more effective. My experience has been, though, with larger teams that have tried doing that, it still doesn't go as fast as what you have with a small team. And I think some of that has to do with the fact that you do the experiment, but then you've also got to disseminate the information to make sure everybody's on the same page. And with a larger team, that's still just harder to do. I haven't seen teams that were really good at completely segmenting it to where these people did the experiment, they implement it, and no one else has to really know about it. But I think that could work if you're really, really careful how things are segmented. Okay, and last takeaway is make sure you're focusing on the return on investment. If you know that statistically it is unlikely, if you know that statistically a large team is only going to finish about a week sooner on a half month or a half year project than a small team, you want to be very careful not to spin up a large team, knowing that it's going to cost you $1.8 million more, but knowing that the value of that week is really, really low. So thinking in terms not just of when are we going to be done, but what's the return on investment from this based on the team size that we're working with. So there's like I said, this was a 30-minute talk. So there's the takeaways that I found useful from looking at this data. I wanted to mention a few things. This has been going on right now. We've got a small group of people that are going through these books, and then we're discussing them once a week. This was a paid class option. This has been one of the highlights of my week, is getting together with this group and really talking through what these business books teach us about being able to manage agile teams and what they teach us about the agile principles. If this sounds interesting to you, I was going to throw a link up here in the chat. If you sign up for this, you can see the summary we use for the 5 dysfunctions of a team. I highly recommend checking that out. It's very, very valuable if you haven't read the book, or even if you have and you just want a 12-minute video refresher of it. But also signing up for this will get you on the list when we start, when we do the next one. So if that sounds interesting, put your email in that link, or if you're just interested in checking out the summary, that's great. Love to have a part of that. Other things I want to mention is here are 2 links. This is the YouTube link to the Agile Lunch and Learn. So this will have, my wife's going to paste that there. This has all the, okay, so the first one there, yes, the first one here is the recording of the streams. If there's ever a talk that you miss, you can go to here and it should be there if everything goes correctly. So I saw somebody had to drop off early today. You can go catch the last of a talk if you meet it, or pass it on to teammates. So if there's any talk that you thought was particularly good, or a section of it that you thought you wanted to share with your team, this is where you go to get those. I'd love for you to pass those on if any of those seem useful to you. The other one here, the Agile Cartoon playlist, this is at youtube.com Mark Shed. And it's a list of cartoons dealing with different aspects of Agile. A lot of teams have found these were really useful things to watch through as a team, even if they talk through it and they say, I don't agree with this. Even if you say you don't agree with what Mark said here, that's probably a very productive conversation. So even watching through these and saying, you know what Mark says, and talking to the users with those aliens, I don't agree with that. Letting the team talk through and work through those things is going to be very, very valuable. So I know some teams have taken this and they just once a week they carve out 5 or 10 minutes at the beginning of their daily stand-up to watch one of these and discuss it just as part of their weekly process. So if that sounds useful to you, the link's there. The Agile Cartoon playlist is there with all the with just the cartoons listed. There's other things on that channel as well. Okay, well, that wraps it up. How did I do on getting 30? Okay, I went 6 minutes over, but we were aiming for 30 minutes today as a kind of a challenge. But thank you so much for coming. Hope to see you next week. Remember, we've got Austin coming to talk about mob programming. I'm really looking forward to that talk. If you've got anybody in any groups that are looking at doing mob programming, pass that invite on to them. I will be sending it out here just in a few minutes, so you should get that. Pass that on to them and see what parts of your team might be interested in coming and learning about mob programming. So thank you very much for coming. I will stick around in case anybody's got any questions. I'll stop the streaming here. But thanks and hope to see you next week.